IB Physics, May 2024, Time Zone 1, SL Paper 1, Question 5. An object is released from rest and slides down a frictionless ramp. The object then leaves the ramp and slides along a rough horizontal surface. The object stops in a distance s along the ramp. The coefficient of dynamic friction between the object and the rough horizontal surface is mu. What is the height of the ramp? All right, so initially the object has a potential energy of mgh. And since this is a frictionless ramp, we can assume that all of that potential energy is converted into kinetic energy. So by conservation, the kinetic energy at the bottom of the ramp is going to equal to mgh. And work is equal to, sorry, that equal sign isn't that great. Work is equal to the change in kinetic energy. So in order to get to a speed of 0 for the block, we're going to be losing all this kinetic energy. So we can also say that work is equal to the force of friction, in this case, times the displacement, or just distance s in this case. And then that would be times cosine of theta, but cosine of theta is equal to 1. So now we need to find the force of friction, and this is dynamic friction, so the force of friction is equal to mu times r. R is the normal force. Well, the object would be acting with some weight into the ground, and weight is mg, so the normal is opposite of that mg. And this isn't on a ramp or anything, so we don't have to deal with components. We can just say that the force of friction is equal to mu times mg. So now let's plug this in. We have mgh equal to the force of friction, which is mu times mg times the displacement s. Now this mgh is coming from the change in kinetic energy. Well, the m and the g both cancel. We're left with h is equal to mu times s. That is answer choice D.